Hi and welcome to my channel Math, ML and Code. Today we're going to be discussing about logarithms, specifically logarithms of products of functions, how to change the basis of logarithms and solve equations that involve logarithms. So first of all, let's just try to understand what the log of a number really means. So let's say we have an example of y is equal to log 2 with respect to a base b of a certain number x. So what that expression basically means is what should be the power of the base b such that raising b to that power will be equal to the number x. Okay, so in other words, basically what we're trying to see is what should be the value of y such that b raised to the power of y is equal to x. Okay, so in simple words, that's what logarithms really means. So let's just go over some basic properties of logarithms to get them out of the way so that we can move on with with problem solving. Okay, so property number one, if you're trying to calculate the log with respect to a certain base b of a variable x raised to a certain power p, that can be written as p multiplied with log to the base b of the number x. Secondly, if you have log of a composite of functions, such as you're trying to find the log of multiplying two functions together or dividing two functions together, so that can be simplified as well. So if we have log to the base b of x multiplied by y, that can be simplified as log to the base b of the number x plus log to the base b of the number y. Okay. Similarly, you can do the same thing for divisions of variables as well. So if you're trying to find out log to the base b of x over y, that can be simplified as log to the base b of x minus log to the base b of y. So these are the most commonly used properties of logarithms, and they're very helpful when you're trying to solve equations that involve log. So one important topic that I just wanted to cover before we move on to solving equations with log is how to change the base of a certain log. So changing base of a log expression. Okay, so let's just take an example over here. Let's say we have a certain number k that is equal to log to the base 4 of 16. So if we have k being equal to the log with respect to base 4 of 16, one way to convert this particular log expression from base 4 to a base 10 to base 10. Okay, let's just try to convert this particular expression from log to the base 4 to a base of base 10. So this can also be written as k is equal to log to the base 10 of 16 divided by log to the base 10 of 4. Okay, so basically what we have done over here is that we converted the expression that involved having a base of 4 to an expression that involves having a base of 10 that we normally deal with. Okay, it's just easier to deal with a base of 10. Okay, so just a side note over here that some bases are more commonly used than other base numbers. So because of the applications in computer science and physics and engineering, some of the commonly used bases are 10, which is the most commonly used base, a base of 2, and a special base of the number e. Okay, so whenever you have a logarithm that involves a base of e, we normally call that as natural logarithm, which is given by the shorthand ln. Okay, so going back to this particular problem over here, so what we're trying to do now is, this was just a conversion from base 4 to a base of 10. What we'd like to do over here is change from a base of 4 to, let's say, to a base of 5. Okay, so we want to change base to 5. Okay, so change the base from 4 to 5, but it has to be done in a certain way such that after changing the expression from base 4 to base 5, the value of this particular constant k does not change, it remains the same. Okay, so k remains as k, but the expression will you read it in terms of a base of 5. So the way we can do that easily is by basically using this particular property of changing the base to a base of 10. Okay, so let's just rewrite that. So if k is equal to log 16 base of 10 divided by log 10 to the base of 4, you can rewrite that as just by taking out the log with base 10 to 4. So 1 over log 10 of 4 multiplied by log 16 to the base of 10. So in order to change from base 4 to base 5 as we need over here, all we need to do is divide this particular side by
I didn't understand
log
that.
5. So I'll just go to a new page and rewrite that. So we have k is equal to log 10 of 16 by log 10 of 4. So in order to change from a base of 4 to a base of 5, all we have to do is multiply and divide this particular expression by log 10 of 5. So the way the way this is easily done is you can rewrite that as equal to 1 divided by log 10 of 4 multiplied by log 10 of 16, and then multiply and divide by log 10 of 5. So multiplied by log to the base 10 of 5 divided by log 10 of 5. So I mean, in fact, we haven't really changed anything. Multiplying and dividing by log 5 does not change the expression, but now we can rearrange that and convert this to a new base. So k is equal to, we'll just bring this expression on the top over here. So we have log 10 5 divided by log to the base 10 of 4 multiplied by log 16 of base 10 divided by log to the base 10 of 5. Okay, so if you look now closely to this particular expression, we have just two of these simple groups. So we have one group over here, and we have multiplied by this particular group over here, this expression over here. Okay, so now just inverting the same process again in order to get back our expression. K is equal to log to the base 4 of number 5 multiplied by log to the base 5 of the number 16. Okay, so if you look closely to this particular expression over here on the right side of this particular expression, what we did was we have changed the base from 4 to a 5, but that involved multiplying by a new constant, which is log to the base 4 of the number 5. Okay, so you can actually generalize this. So you can write this as k is equal to, if the new base, let's say if the new base is written by b sub n and the old base is b sub o, you can generalize this as log of the old base of the new base. So log to the old base of the number new base multiplied by log with respect to the new base of the number 16. Okay, and that is what we were trying to achieve over here. So far we have seen how to change the base of a certain log. Going back to a change of basis, again, if you have log of any number x with respect to a base e, that can be written as natural logarithm of the same number x. Okay, so normally we don't really call that log to the base e of x. That's just called natural logarithm of x. Let's just go over a couple of examples before moving on to solving equations. So let's say we need to calculate log to the base 2 of the number 80 minus log to the base 2 of the number 5. Okay, so if you wanted to, you could do it in two different ways. One way, and a slightly longer way, is to convert both these bases from base 2 to base 10, and then just use your calculator to get the final answer. So you could write this as log base 10, the number 80, divided by log 10 of the number 2 minus log with respect to base 10 of 5 divided by log with respect to base 10 of the number 2. Okay, so just plug that into your calculator and you will be able to get the answer for that. And by the way, the answer is supposed to be 4. Now a more compact way to do the same problem, and maybe a more easier one, is to use the property of log in order to write this in a more compact form. So the way this can be written in a more compact form is, because we have a minus sign over here, we can rewrite the same expression by using division of the two numbers. So you could write this as log to the base 2 of 80 over 5. So that's just the same as writing log to the base 2 of 16. Okay, and that will again give you the number 4. Okay, so a very common mistake that most students make when they're trying to solve problems involving log is basically, just going back to the same property of using logarithms over here. So property number 2, when you're trying to simplify logarithms of two variables being multiplied together, that only works when they are being actually multiplied together. So if we have expression that involves sum, log of a sum of two different variables does not work the same way as you see over here. So I'll give you that example over here as well, just to clarify that. Okay, so if you are trying to calculate log of x plus y, okay, that is not equal to log of x plus log of y. So that's a very common mistake that students trying to learn logarithms logarithm make in their early in the course. So just try to avoid that. Okay, similarly, again, just to give you another example on this, again, log of x raised to some power p1 plus y raised to a certain power p2 is again not equal to p1 log of x plus p2 times log of y. Okay, so just be careful when you have these sort of operations involving logarithms. The property of finding logarithm of a composite of two different functions does not work the same way as the product. Product is defined. The sum over here is not defined the way that you see over here. Okay, so now that we have some common properties out of the way, we can move on to solving simple equations that involve logarithm. Let's just go to a new page. Okay, so let's say we have this particular equation that we need to solve using logarithms. Let's say we have 2 to the power of x multiplied by 4 raised to the power 3x, that is equal to 60. Okay, so you have 2 to the power of x multiplied by 4 to the power of 3x, and that is equal to 16. Okay, so again, these are two separate terms. What I meant to write was 2 to the power of x multiplied by 4 to the power of 3x, and that is equal to 60. Okay, so easiest way to solve this sort of problem is to apply logarithms directly and try to find the value of x. Okay, we need to find the value of x. Okay, I'll show you the solution in two different ways. One is the more direct application, which you just transform the equation using, let's say, using log with a base of 10. Okay. By the way, if I write just log, it just basically means log to the base of 10. So if you take the log of the entire equation, log of 2 to the power x multiplied by 4 raised to the power of 3x is equal to log of 60. Okay, so let's just simplify this. That leads to log of 2 to the power of x plus log of 4 to the power of 3x, that is equal to a constant log of 60. So again, we can just simplify this out and write it out. This would be x multiplied by log of 2 plus 3x multiplied by log of 4 that is equal to log of 60. Okay, so that is now we have converted the power form of the equation into a linear equation, as you see over here. Okay, so beyond that is just simple linear algebra. We can factor out the x and find out and solve the equation. So factoring out x, what we're left with is log of 2 plus 3 times log of 4, that is equal to log of 60. Okay, so we just take that on the other side and get the value of x. Okay, so I'm just going to write this out. X is equal to log of 60 divided by this whole expression that you see on the top. So that is log of 2 plus 3 times log of 4. Yeah, and that is the solution for the problem that we have on the top, which is 2 to the power of x times 4 to the power of 3x is equal to 60. Okay, so that's the first example. I'll just change the colors to write down another example over here. Okay, let's say we have another problem, second problem over here. We have f of x is equal to 3 to the power of x minus 5 to the power of 2x. Okay, and the problem that we are trying to solve in this particular equation is we're trying to find the roots of this equation. So roots basically means, so we need to find basically the root of f of x. Okay, so that basically means equating that equation to 0 and then finding out the value of x. Okay, so let's see how to solve that problem as well. Let's go to a new page. So the problem was 3 to the power x minus 5 to the power of 2x. So you can rewrite that as 3 to the power of x minus 5 to the power of 2x. That must be equal to 0 in order to find the roots. Okay, so as I said, I mean, in the previous problem over here, there were actually two ways to solve this particular problem. I'll come back to the second one once I show you how to solve this particular problem over here. Okay, so we can rewrite this as 3 to the power of x is equal to 5 to the power of 2x. So this is again a very direct application. Apply log and transform that into a linear equation, basically log with respect to base 10. So we have log 3 to the power of x is equal to log 5 to the power of 2x. Okay, so simplify that, we get x log 3 is equal to 2x log 5. So again, just factorizing it out, so we can just rewrite, get that term on this side again and then just factorize, you get x log 3 minus 2 log 5 is equal to 0. Okay, so if you just see this particular expression, basically what that means is x is just equal to 0. The solution is x is equal to 0. Okay, so that basically means when x is equal to 0, basically the roots of the function lie when x is equal to 0. So just to verify that and see if the solution is correct or not, let's just plug this value back into this problem over here and see whether we really get 3 raised to x minus 5 raised to 2x equal to 0. So if you plug into the equation again, you get 3 to the power of 0 minus 5 raised to the power of 2 times 0. That is equal to 3 to the power of 0 is 1, 5 to the power of 0 is also 1, and that is equal to 0. Okay, so the solution is correct, and the solution that we have over here is that the root lies at x is equal to 0. So going back to the old problem again over here, which is 2 to the power of x multiplied by 4 to the power of 3x is equal to 60. I'll just copy that over there so we can work on this again. Okay, so let's just try to solve the same problem again, but using a second method. Okay, and that method might be slightly easier or slightly shorter than the one that we have seen that we saw in the earlier approach. In the second approach, what you can do is you can see a pattern in the bases. The base over here is 2, base over here is 2, and the base over here is 4. You can actually write the number 4 in terms of the number 2. So basically what we are going to do is this part will remain as it is, which is 2 to the raised to the power of x multiplied by 2 square raised to the power of 3x is equal to 60. Okay, so just observe what we have done over here. 4 can be written as 2 to the power of 2. Okay, so basically what we have done over here is that we just have base of 2 over here and a base of 2 over here. So simplifying that, what we already have over here, so we get 2 to the power of x multiplied by 2 to the power of 6x, because 2 times 3x is 6x, is equal to 60. Okay, so since we have the same base 2 and base 2, and we have exponents of x and 6x, we can just combine them into one single expression. So what we get is 2 to the power of x plus 6x is equal to 60. Okay, so we haven't taken the we haven't transformed the equation using the logarithms yet, because we're just trying to simplify it. So this can be written as 2 x plus 6x is 7x. That becomes 7x. So 2 to the power of 7x is equal to 60. So after this, we can just take the log again and try to find a solution. Okay, so the equation that we ended up with was 2 to the power of 7x is equal to 60. So we take the log on both the sides again in order to make the equation linear. Just take log with base 10. We get 7x log of 2 is equal to log of 60. Yeah, so from that we can just get the value of x directly. We get x is equal to log of 60 divided by 7 times log of 2. Okay, so that is the solution for the same problem again. So you basically get the same results whether you do it using this approach or the one that we have seen before. Okay, the solution will be the same. That will not change. So in the earlier case, we got a solution in this particular form, but the numerical value of this x and the numerical value of this particular x is going to be the same. They're not going to be any different. Okay, so that's the end of today's video. So if you have been following along for so long, please subscribe to the channel to get more regular updates. I'll be releasing more videos on topics that broadly tie into the topic of machine learning and other calculus-based topics. And please don't forget to hit the like button. That will just help the channel get more visibility on YouTube and get the video to the people who might need it. Okay, so see you in the next video.